problem 5.3, they're giving you a set of cards and they want you to match each equation. Let me just highlight the directions here for you. Match each equation to either a graph or a description. So I basically just took the cards and I moved them up to the right of your screen, and then here are all the equations on the left of the screen. One of the biggest things we need to keep in mind and remember from Unit 7 with all of our quadratics, and particularly in this unit on polynomials, is that anytime you are finding the zeros of a function, so anytime you're finding the zeros, you are also finding the x-intercepts. This is going to be super important because this is how I'm going to help match the graphs, the functions on my left with their graphs or their descriptions on the right. So if we take a look at the first function, y equals x minus 5 times x minus 4 times 2x plus 3, if I find it's 0, if I find when the function equals 0, right, I'm finding the x-intercepts. So there's 3 factors, and just like in problem 5.2, we want to know what makes each of them 0. For the first one, it's going to be positive 5. The second one is going to be positive 4. And then this third one is going to be, we could do the little bit of solving to figure it out, right? Minus 3 to bring it over to the other side. Divide by 2, and you're going to get negative 3 halves. Negative 3 halves is the same as negative 1.5. So if we want to find a polynomial that has these exact 3 intercepts, and it's x-intercepts, not y-intercepts. So if I go and I take a look at the cards with the graphs on them, I'm looking for a positive 4, a positive 5, so they're really close to each other, and a negative 1.5. And that I can find right over here in card number 4. So there's a positive 5, a positive 4. So my x-intercepts are at positive 5, positive 4, and then halfway between negative 1 and 2, so negative 1.5. So I'm going to go ahead and match card 4 with this function. So matches with number 4. And I'm going to go ahead and let the zeros, finding the zeros of each of these functions, which are the x-intercepts, I'm going to help that match them with their graphs and their descriptions on the right. So if we look at the second function over here, we've got x plus 5, and then we've got the factor x plus 4 and the factor 2x minus 3. So we want to know when it equals 0. And we know the first one's going to be at negative 5. We've got negative 4, and remember in this case it's 2x minus 3, so if we were to solve it, you're going to add 3 and then divide by 2. So these are my 3 x-intercepts, negative 5, negative 4, and positive 1.5. I see that right here on card number 6. So my x-intercepts are at negative 5, negative 4, and positive 1.5. 3 halves is the same as 1.5. So we're going to match card 6 with this function. So card number 6. If I look at the third function here, x minus 5, x plus 4, and then 2/3 plus what, 3, we know that the zeros are going to be at positive 5, negative 4, minus 3 divided by 2, minus 3 divided by 2, or another word for negative 1.5. So if I look over on my cards, I've got positive 5, negative 4, and negative 1.5, or 3 halves. That's card number 2. Positive 5, negative 4, and negative 3 halves. So we're going to match card number 2 with this graph. Card number 2. Moving on to the third or fourth. You've got -5, +4, and then minus the 3 and divide by the 2. I want to keep my colors the same. Let's do that again. -5, +4, minus the 3, divide by the 2. So we're looking for a graph with x-intercepts at -5, +4, and -3.2. I've got a -5 right here. I've got a -3.2 or -1.5 right here and a +4. So card number 8. So -5, -1.5, and +4. Card number 8. All right, on to the next one. So this is kind of neat. I noticed that each of my factors have minus signs in them, so I know that my x-intercepts are going to be all positive. +5, +4, add the 3, divide by the 2. So this is a polynomial with 3 positive x-intercepts, and that's going to relate to card number 3. Card number 3 is a polynomial with only positive x-intercepts, and that's going to go with this function. And I can actually use that same logic with this next one. All 3 of my factors have plus signs in them, so that's leading me to believe that I have all negative x-intercepts. So 1 at -5, 1 at -4, minus the 3, divide by the 2, and that's going to match up with card number 5. Card number 5 is only negative x-intercepts. So if we take a look at our last 2, so we got card number 1 left and card number 7. And I've got 3 factors. I've got, when do they make 0? When's this function 0? So at +5, -4, add the 3, divide by the 2. So I've got a +5. Oh, there it is. So I've got a +5, a -4, and then a +1.5 for my x-intercepts. And then that's card number 1. It's going to match with this guy. And we've got number 1, which means last but not least, card number 7 is going to have to match. But I'm just going to do it to make sure. So you've got a 0 at -5, a 0 at 4, add the 3, divide by the 2. So here are your 3 zeros, which are your 3 x-intercepts. So -5, yep, that works. +4, and perfect, 1.5. So they do, in fact, match. Card number 7 goes with this function.